Now let's begin the first set of presentations with Pydantic Crafting Confidence in AI Apps by Gediminas Sadaunykas.
Hello, hello. Okay, good to see so many of you here, and let's begin. So, yeah, so hallucinations, unpredictable outputs, and inconsistent reasoning been quite a significant hurdles in applying large language models, basically to the production environments, up until the very recently. With tools such as Pydantic, we can inject quite a lot of confidence and structure in our AI apps. So a little bit about me. So yeah, I have background in economics, statistics, and data science, but most my data science experience comes from different domains. So I started in sports domain, then moved to the medical information, and now currently I'm in Zedge doing the digital product analysis. Yeah, I'm also a lifelong fan of mixed martial arts, and I do love grilling on my Kamado, so that will explain why you will see a lot of food references here today. So this is our presentation plan. This is actually, yeah, so 3 piece, Pydantic, Poetry, and Pancakes. We will try to see how understanding each other can complement our overall grasp of agents and structuring. Right, so most of my career, at some point in each place that I worked in, I had a document processing project at some point, and document processing can really fall into very similar pipeline or the standard process. So you get the raw document, you do some pre-processing, you do the OCR to extract the information, do some cleanup, you do the classification, which actually it's a real case. I actually had to classify whether it's a cat, a food, or actually a true valid document. You did some feature engineering, and you prepare it for the downstream machine learning task, which could be the name entity recognition, summarization, or any other. And you do some post-processing, and the document is ready basically for the downstream system or the insights. So this is ML part, this is ML part, and this is ML part. So, and because these are machine learning components, they can be fine-tuned, they can have their own versioning, their own data, their own parameters, and the whole system can get quite complex. And so how the document processing changed with GPT? So like a lot of things changed. So basically you get a raw stuff, you just throw it in the large language model, and you just hope for the best. And to be honest, it actually works. Yeah, it's obviously a huge simplification, but this is actually true. A lot of those components that we saw before, we can actually replace it by the configurable or the certain instance of the large language model call. And you would model that particular call with Pydantic. And it was made possible, I would say, last year with response modeling, which we now probably know more often as a structured output. It is now basically kind of LLM 101 on how we actually do that. But yeah, 2022 now seems such a long time ago, you know, but at that time that the best that we could hope for is just ask GPT to produce a parsable JSON like it life depends on it, you know, and it still kind of failed, and failed very creatively, I would say, often. Right, so very quickly, what can we see, how can we understand the response model? So it's like a ice cube tray or ice cube shape, and basically you are creating it during the runtime for your specific context, for your specific environment, and the large language model task is basically to pour water or to pour in information until it freezes into your desired shape. Right, so let's make some pancakes. So a response model for pancakes could look something like that, right? Let's say that we want some nutrient density, we want to know the texture, the ingredients, for example, what the side dish is, and we would build this model, and we can use it to extract the pancakes, for example, from movie transcript, books, internet, recipes, and when we're building a response model, we can understand it as building a very structured prompt. So everything matters. So the class names, the variable names, type hints. Field is becoming a very important data type because you can add a lot of contextual information about your field. And we can see we can make a use basically of Pydantic validation. So here, for example, we would Pydantic would reject any pancakes which has the side of banana or the watermelons, and the language model would have to correct itself. So this is our model, and how this model fits into this. So before the structured outputs became part of many clients, Instructor was a library that you could wrap most of the clients and basically add your response model as an argument, and you're guaranteed to get an object back, which is very useful. Okay, so now we are in the era of agents. So, and basically at the end of last year, we got a new kid in blog basically when it comes to agent frameworks. So we got the Pydantic AI, which actually really extends nicely into basically the principles that we learned from the single large language model called structuring. So here we still need a response model, so we can extend it, for example, because now we are building an agent. Yes, so the virtual chef, which needs to do some many steps to give us the breakfast, the pancakes. Actually, we're not being very choosy. So, and yeah, so response model dependencies act as a kind of outside source of could be connections, parameters, settings, clients, which the agent can use throughout this basically run lifecycle. And the tools. So the tools is probably the most signature part of an agent, and you are defining it very similarly with very informative docstrings and type hints, so that the model would know which one to choose, and to choose many times the single tool or in any other direction to really give us the output that we want. And how it is added together to make an agent. So yeah, we have the model, dependencies, output types, system prompt, and tools. So we can think of an agent basically a model shaped by our system prompt, which tries to give us the output that we defined using the tools that we provided based on the dependencies. So this is basically the agent structure based on Pydantic. Okay, so quick demo. So it's not gonna be fully live demo. So we're just gonna look into some code snippets. But so I myself have never read the Harry Potter, and it's actually. And sometimes, once in a while, I really find myself in a situation where I don't get the references, the jokes, or some. I'm just feeling the missing out. And let's say that we want to build an agent, which basically, and let's assume that I don't even know how to start and how to properly understand the book. So let's try to build a two-agent system. So the process manager and process executor. So this is a very common agent design pattern. So the process manager knows it has a context on how to solve the problem, and the process executor actually goes and does that. So the process manager will have access to the context on how to actually read a book, and the process executor will go and try to give us the information on the Harry Potter. And yeah, so both the process manager gives us the plan in a DAG format, and this process executor also gives us a DAG, so the step-by-step steps on what is being done. So what we want is basically both these things to be very similar to know that our system works properly. Right, so let's let's go into code a little bit. So yeah, I think you can see. Yeah, so I will skip. I will go quite quickly, but I will make sure that this notebook is publicly available so that people you can see. Yeah, so we start with system prompts. So that's how I like to define the system prompts. So the agent role, objective, directions, or the constraints. So yeah, we are just telling that the model is what they are just bragging that it's the best in the world at doing something. I don't know if it works as well as it used to be before, but it's still probably from the habit of doing it. But most of the time, really, the system prompt should be only the supporting material. Most of the things should be really in your response model to be able to get the output that you want. Dependencies. So here, for example, we're just adding some that we want to have the 65,000 max words in our process and the task. So our how to book and our Harry Potter book to manage the context. And the temperature. So yeah, let's say that we want our planner to be a little bit more flexible and creative than our process executor. Just it is more evident when we are doing more runs and just sampling the best solution. So it kind of helps to get out of probably suboptimal place and just find some more creative ways to do things. But when we were doing single call, it's not that relevant. Paths, and basically it is our dependencies. So this is just where to find the information. Yeah, this is bread and butter. So response models. I really like adding confidences in my response models. They're very far from the confidences that you know from the mathematical sense. That is basically, and it's can be very misleading. But I find that it's often very useful, at least for yourself, to see how the model grasps its own kind of knowledge. And yeah, it's usually overconfident, but still. And this is how we are creating basically our abstract process and the execution. So both we want to be DAGs, so ID and the dependencies is probably the most important thing. And yeah, and we want our process planner to be able to build as a plan from the process steps. So this is just the helper function to create the markdown later, and our process plan just will have a list of steps on what to do, basically on how to properly read and analyze a book. This is the function to check whether it's actually a DAG. So it uses the networks basically library, and the same for the execution, right? So two different objects, but actually both are DAGs consistent of steps. And finally, we want our final model to be to have a plan, to have an execution, to have a confidence on how closely the plan, the execution followed the plan, some additional analysis if we wanted to add something else besides the context provided by the planner, because that's what you usually do. Usually combine your domain knowledge and the AI knowledge. And this is just a big Pydantic functions to really check on how similar those two plans are, just to provide again errors if it doesn't. So it's like the next step after the confidence, which is more deterministic, to make sure that we're getting the output that we want. Okay, so this is some dump tools just to read the context, to cut the context if it's too long, and basically to check if it's the correct context length. And basically, and there's some smart tools. So both our manager agent and the executor agent will have access to the large language models. So the planner will have the access to create the execution plan. So it will call the LLM model and give us back the plan, and the execution plan will actually take the input, a process plan, and will give us the execution results. So this is kind of, we're trying to build something very abstract and to be used general. And yeah, let's have some fun. And basically, we're adding some custom step to analyze basically what are the food tastes in Harry Potter. So what the characters like, and the character similarity based on the food that they like. And basically, we're trying to find all the pancakes in the book also. Right, so this is just the models that we are adding to the agent, and this is our agent. So this is our executor agent, which will have some tool to manage context. This is our custom manual analysis tool, and this is actually the tool to call the LLM to actually execute the analysis. And our manager agent, again, we'll have the tool to manage context, the tool to create the execution plan, and actually to execute the process. And this is agent-agent relationship via tool. So this is one type to manage, to create basically agent-to-agent communication, is basically agent-to-tool relationship. And yeah, so basically, okay, so what are we, yeah, so what are we getting? Let's see. So this is actually what our planner agent came up with. So it basically came up with this plan on how to actually go about and to analyze the book. So we can see there is literally elements, the symbolism, the character development, which I probably would never came up with myself if I, for example, went on and tried to dig deeper into the literature. And this is our custom steps. So this is find the food, all food mentioned, and the character similarity. So these are defined by us. And this is the final report that we are given. So this is process plan. So we can see that it adds what is expected from this step, what basically on the high level should be thought or the analyzed about. And basically, and the next goes the process execution. So we can see the confidence, the reasoning behind the confidence, so that the model had all the information basically it needed to, at least based on its own opinion, to grasp basically this particular step. And some story patterns. So hero's journey, coming out of age. Yeah, it's very concise. It's very bullet point. But if we wanted to have something wider, we can definitely ask. But this is, I think, is very useful. And some additional stuff, right? So we asked about food. So it kind of finds that Harry ate bacon, porridge with sugar. So it definitely had a lot of dead rats, and it definitely didn't sound very tasty. And basically, yeah, so and Harry and Ron share similar tastes, so they are very similar in what they eat. So I don't know. Yeah, I definitely haven't fact checked it, I know, but it would be fun if it hallucinated this relationship. But yeah, and there is no pancakes in the book, so that's unfortunately. Okay, so basically we saw how we can apply this process manager, process executor kind of analysis way to analyze the books, but I had some other basically tests to apply very similar process to analyze. So we had this EU AI Act, which was like a big document, a big document on really how the AI system should comply, and it's a huge 400-page stuff that probably, I don't know, only the few glorious people read it. But you definitely need to adhere to those rules. So on one hand, we can have a process manager which basically keeps track on what are the compliance rules, on how the AI system could be analyzed and risk analyzed. And on another hand, you can add actually, yeah, so this is AI Act. On another hand, you can, for example, add your system diagram with the description on what are the data inputs, outputs, what are the technologies used, and you would be able to get, yeah, so this is basically the big plan on how to, based on the EU AI Act, to analyze your AI system, and this would be the compliance mitigation plan, so specified basically for your particular AI system. So again, I'm not planning to replace lawyers and everything, but it's definitely a useful thing to know, basically out of the box and quickly, I think. Okay. Right, so yeah, so basically my little prediction for 2025 probably would be, it's probably now more than an observation already. Is basically that we will have a time of communication modeling with the tools, with a protocol such as MCP, which we already have, the A-to-A, the agent-to-agent, so both within the agent and between the agents, which I think really will allow us really to make our agentic systems much more, much less of a hype and more of a useful tools. Yeah, and to sum up, probably, yeah, if I had to do like one most point, at least what I've learned over the last couple of years, that that the sheer kind of raw power and the logical reasoning of AI seems like to be expanding so quickly, and what you're left off is basically just to engineer control, interpretability, and robustness, and basically the tools such as Pydantic really gives us freedom to and the flexibility to do that. Right? Thank you very much.
Do we have any questions from the audience? Raise your hand if you have.
Can we get that notebook from the code?
Notebook. Oh, okay. yeah. I will upload it to the public repo. Yeah, I will make sure it's the link is publicly. Huh? Do we have the Facebook or Discord? Yeah, so that's probably the proper place. Yeah, I will upload to Discord.
Questions?
Thank you for the presentation. My question was, when you work with LLMs, you basically struggle with the context size of the context size. So processing the whole Harry Potter book would be a challenging task. So how do you manage to do this? I mean, to find the exact answer to your question.
Yeah, so the text, basically the long knowledge chunking, and it's basically, it's another probably big topic. Ideally, and it's tricky because for the different downstream tasks, you often need the data split in the different ways. Sometimes you need by paragraph, sometimes you need by chapter. So here I just cut, but what you usually do is would usually find a way how to chunk it logically, yeah, index, rag, and just add, the standard embedding kind of call to refer to that part of the text.
Okay, thank you.
Yeah, so we have another question from Discord. The confidence score given by LLMs are usually not well distributed. How to get more distributed confidences so that we could move the precision recall curve in terms of classification?
Right. So yeah. So the confidence scores is a tricky. So yeah, definitely the confidence stuff that are given by the same LLM is definitely not very useful. So unless you have your own model and you can get basically the probabilistic outputs from the generation, or you need to basically train a separate model which can kind of this critic who would provide you with an actual number, which can actually be a standard ML kind of model.
Another one, how would you connect these agents to MCP?
Right, so MCP, I think Pydantic AI really was quick to make it so that the MCP would be compatible with it. So right, so MCP, the protocol to interact with the tools via the standard protocol, and basically, yeah, so the agent would be a client and the server would be a tool, and Pydantic AI really gives the way to use them. And actually, it's developing a lot of servers already. So the MCP kind of tools of its own.
All right, and the last question, what happens underneath Pydantic? How the model is constrained to give valid structured outputs?
Sorry, what was it?
What happens underneath Pydantic? How the model is constrained to give valid structured outputs?
Yeah, so basically the Pydantic model is serialized into the JSON and basically just send all the structure, contextual information about your model and the data as a structure prompt. And basically these days the language models are actually quite smart. They need and usually the clients handle the retry mechanisms, and most of the time, it's either first or the second time, and the model is able to fill that data model effectively.
All right, thank you. We do not have time for more questions. If you have them, please write them in Discord or find Gediminas and talk to him. So thank you.
Thank you very much, guys.